I've taken down a couple of trees and made them hangers so I could show different techniques. I've done this over the years. This right here is probably the safest one. Take it down with the tractor, especially if you're going to be skidding, use that. I've done this for a long time. Tractor is always safest. Did you see that thing right there come down that branch? Right in the middle of my screen. That came down and speared the ground. Had somebody been there, it would be over. It would have been done. Just a lot of force, a lot of weight. And sometimes it's better to let somebody do it instead of doing it yourself, you know, for the guy who hasn't spent a lot of time in the woods. Because it's a game of statistics, it really is. Dangerous play. Gonna have to use my phone for a camera for a little bit until I am able to purchase some batteries for my main camera, which for whatever reason decided it doesn't want to hold the charge in the batteries anymore. Maybe being out in the rain and in the water a couple of times and just generally being banged around is a reason why. It's getting to the point of the year where the leaves are just beginning to turn. It's going to be gorgeous this next couple of weeks. The temperatures have been dropping down into the 40s. And I got to pull this old thing. It's an ash tree I took down with Bob, and it was out in the swamp. And I had to wait for the water to drain off the surface enough to where I can get back here with the tractor. Finally did. And I have to pull it over its stump, which is how come I cut in those wedges both in the log and in the stump to help get it over the top of that thing. And ultimate old man saw rides in the tractor in case I have to break it in half or cut a tree down to get through. And you can see the waters over there. And there was a conversation online, I think I started it actually, about whether or not you can use a longer bar, like a 28-inch bar on a 60cc or 65cc saw. And of course the answer is yes, because I was doing it with my Jonsered 2165 that I had built a while back. And while I was doing that, while I was going through that whole process, I started looking at some of those videos I had done on that Jonsered build. I think I did like 5 of them. And at the very end, I had done a test. I had done a kind of a cookie cut race between some of the builds I had done over the years. And I had a 2172 basically stock. I had a 365 Husky built kind of the same way, but really in retrospect not the same way. A couple other saws. And realized I really never did the follow-on on why the Jonsered 2165 ran so much stronger than the Husqvarna 365. And as I was going through the videos, I realized that just a lot of that information is packed in those older videos. And I really never boiled it to the top, because rather than being a educational style of a channel, I just kind of want to just document the history of things, let people sort of figure that out on their own. But I've seen some subsequent videos on similar type builds and things like that, and realized that maybe some of that stuff should be focused on a little more. You know, I've been trying to avoid the saw mod thing and getting into the theory. You know, kind of went there, then bounced out of it, because, you know, I'd rather be doing things that pretty much anyone can do, that whole tools from Lowe's concept. But in the pile of videos, there are some nuggets of gold for those who like to modify saws. And in particular, the difference between that Husqvarna 365 build I had done and the Jonsered 2165 are some very, very, very interesting things for a person who likes to build saws to run faster. And I think what I'll do at this point is I'm going to break and show the speed tests between the two builds.
let's see if this one restarts. The other 48 millimeter has got it all over this one in terms of power.
And then I'm going to focus on the differences between those two builds and try to spice in, as I'm doing the narrative, some of these differences. Now, the first and most significant difference between those two builds is the air filter and the cover. At this point, I should show a picture of the two different air filters and, more importantly, the two different covers. Because that one thing alone made the biggest difference in how the two saws ran. Now notice that both these builds had the X-Torq Carb modification, to where I took a standard original edition intake manifold, cut the little tab that has the pulse line through it, and then rotated it to match the screws on the X-Torq carburetors, which are at a different orientation than the original edition carburetor. Maybe I'll insert some of that now. The original edition style boot. A carburetor. Well, I'm going to cut that boot, rotate it, so I can use one of these mini X-Torq carburetors, and I'm not sure which one I'm going to use. On the carburetors, most should just stick with the original edition version. I'm going to use the X-Torq carburetor because it has a little bit bigger bore. I mean, we can argue about the theory, because really, are you going to make a big difference? Because the inside diameter of the boot hasn't changed, right? Now, both these carburetors on both saws has the little plate on the inside of the carburetor, the separator, still in the carburetor. So you have raw air going over the top, and then you have a divider, and then the air going across the jets. It seems to run better by leaving those in, so I'll do that. But the filters themselves are radically different. And this is the point. The larger air filter has more surface area of air filter exposed to let air in than the closed small air filter on the 365, which not only is a smaller air filter, but the smaller air box and cover constricts a little bit of air, but more importantly, the filter actually pushes up against that cover. And I think that right there is the key, where the one smaller air filter is in fact somewhat constricted, where the bigger air filter is wide open, allowing more air into the system. And that one little change right there, I believe, is the biggest difference between the two saws. Now, that alone doesn't answer the question. Two-stroke theory has been hashed and hashed, and what I'm just going to do is just give you a basic summary, and just remember that the two-stroke is effectively a pump. And rather than having steady state flow through these things, you have sort of a pulsed airflow through the whole system. Intake to the crankcase. The crankcase gets churned up by a spinning crankshaft and the piston going up and down, then gets pulsed up through the transfers, and the transfers into the combustion chamber where the burning takes place, the power gets made, and then of course out the exhaust. All these things have a resonance or a natural frequency where they like to flow the most amount of air. That's kind of like the dirty little secret, and not going to get into the details, but just that piece alone, you should intuit that you have to have a proper balance. Each one of those systems, each one of those pieces, the muffler outlet, the intake, the carburetor, the filter holder, the crankcase volume, cross-sectional area of the transfers, the length of the transfers, the direction of the transfers as they get into the combustion chamber, the compression, displacement, all these things, they work in concert, right, in order to generate a motor that makes power. And to make the most amount of power, to make a long story short, what you have to do is sort of balance out compromises, and not necessarily things that are working together, but basically make them work as close together as possible, which means you move more gas-air mix through the motor and burn it more efficiently and end up with a motor that actually generates power. And each of these things is a subject in of itself, so I'm not going to get there. But let's make an assumption that both the 365 build and the 2165 have the same compression ratio, because both of them have a pop-up piston and both of them have no base gasket. The squish is the same. The actual compression is roughly the same. Now remember, compression in of itself, that's a concept in of itself that we have to discuss another time, should you guys be interested. But basically, there's like a bell curve to where as you increase compression, the math is something you can actually define. The efficiency of the burn goes up to a certain point. There's a point of diminishing returns. And usually for my saws, I try to get into the 180 range, 180 pounds per square inch. You get past 200, yeah, I mean, there's race saws that'll do that, but there's other things that are happening. Not going to go off into the weeds, but compression for me is about efficiency more than it is about ultimate power. And one of the side effects of having a better compression or a higher compression is more power at lower RPMs. One of the detractors of high compression is it's harder to get the motor to spin. It just simply takes more work. Another concept for another day. Needless to say, the compression on those two saws are the same, so I'm going to leave it right there. And I'm going to use this piston right here. I did this on the first one I built and it worked just fine. I get guys going crazy about how it's inferior for a whole variety of reasons, and it may be, but it works, you know what I'm saying? And it's cheap. It's like 30 bucks. These guys had it to me in 2 days, so I'm going to give them a plug. The product they sell is made by VEC in India, so there's a variety of different places to get them, but they've treated me well, so I'm going to continue to use them. And the reason I'm using this piston is because it has the pop-up. And the reason why that makes a difference is if you look really carefully on the inside of the combustion chamber, it's really not a really good machining. So, I mean, what I should do on this cylinder, if I really wanted to do this saw right, and I just don't have the time, is to take an arbor and go in there and cut the combustion chamber switch band to a flat, and then mill the corresponding distance off the base of the cylinder. And it's going to run good enough with what I'm doing to it that I'm not going to go to that extra step just yet. That might be a future video. The pop-up on this, what it really does is it reduces the volume of the combustion chamber. And I'm not going to get into a whole lot of theory right now, but I prefer the pop-up concept when I drop the cylinder because I have less interference at bottom dead center with the piston and the transfers, which means I don't have to do as much grinding on the transfers to still, you know, achieve the performance I'm looking for. And I get a very simple compression increase, which is what you do when you drop a cylinder. But because it's a pop-up versus just dropping the cylinder, the interference of the piston at bottom dead center is quite a bit less. One of the anomalies when you start talking about porting and stuff like that, again, I'm just going to brush over it, is you see builders, well, they'll machine the base of the cylinder, you know, a lot, 40 thousandths. Well, that makes that thinner, right? But you're also increasing the compression because that's usually why you do it, is to move the whole cylinder down. It does some things to port timing and it does some things to compression that people like. But when that cylinder has moved down, say 40 thousandths, and the piston's where it was, that means the piston interferes 40 thousandths at bottom dead center into the transfers when they're supposed to be wide open. They're now somewhat closed by the piston, plus there's a sharp square edge of that piston. You know, imagine this muffler, imagine that being the transfer, imagine this being the piston at bottom dead center. It comes down here, it wants the transfer port to be wide open, but now you move the cylinder down. So now your piston's here, it didn't change, but your transfer port is quite a bit closed off. When you take a pop-up, what you've done is you've machined the top of the piston just a little bit, so you're actually maybe cutting that interference in half, if not more, depending on how much you dropped your cylinder. Which means you don't have to do as much work on the top edge of the transfer in order to get that cross-sectional area back. And one of the things you'll see with the builds is when they've really chopped that base of the cylinder down a lot, you see these like crazy blowdown numbers, and that's because they've had to really change the upper edge of the transfer for two things. One, because you do have that piston interference, you see the guys will really put a sharp angle on the top of the transfer, and what that does is it helps the flow as the gases are coming up from the bottom end, because you have that square edge. By putting the angle on the top wall, you don't have the gases coming straight into the piston, you have it come at an angle and it's a little bit less resistance. So that's one of the tricks you'll see, but also you'll have to recover the cross-sectional area because of that interference, and that's why they raise those transfers so much. And of course you don't want to widen them too much, because going crazy with the width means that ring will go further into the port. So they go up, you know. Port timing, and in particular port area, can help higher RPMs. One of the weak links in most of these small two-strokes is the transfers. So if you increase the transfer's ability to flow air, typically what that does is gives you the ability of getting more RPMs or more power at higher RPMs, because you can pass more gas and air through the system. What I did on the 365 is nothing. It's as delivered stock. What I did on the 2165 is I modified the lower transfers, but not the upper transfers, and not the timing that much. The timing was altered because of the pop-up piston and because lowering the cylinder, but not enough to really make a big difference. The big change and the big difference between those two cylinders is what I did to the lower transfers, and I will show a picture here. This is what I had done to the 2165. And this was not done to the 365. So now you have two changes that I think are rather significant that are different between the 365 build 2165. One is air filter and how it's constricted on the 365, completely open and free on the 2165. And two, I opened up the lower transfers on the cylinder, and I did that on the 2165, but not the 365. So both those changes will affect the power characteristics of the saw, and therefore define a difference between the 365 and the 2165, which is significant, by the way. Now, while I'm talking about that, I have to say one more thing. You know, I know these guys get kind of power crazy, compression crazy, RPM crazy on these work saws. But the 800-pound gorilla in the room for these small engines is really not how much power you can produce, because you can make a lot, but how much heat your modifications are going to make. One of the woodscraft type things when you don't have a lot of horsepower or a big skidder is how to get over stumps. I think that's pretty obvious. So this is a fairly long tree. Let me see if I can get this thing up over the stump and through the swamp. Now I'd like a little shorter line than that, but it's what I got right now. I may have to back up and rehook. Let's see if it'll come up and over. Here it comes. Now, because it dug in pretty quick, I really can't expect to pull that log because there's no weight in the rear end. So I'm going to give myself a length of chain, see if I can't get out of this hole, get up a little bit on that knoll, and then pull it. I broke off a section, and then pull it to where I can yet again get weight on it. This is a dead ash, but look at the color. This is actually great wood. If it had any life left in it, this would be a nice chunk of ash right here, but fortunately it's not any good. So let me see if I can get out and then have that length of chain to get me out of the hole before I start pulling on that log again. Well, I got the one out just before, and now I'm going to try to hook onto both of these and see if I have enough to pull all this stuff out of the mud, through the mud. But anyway, I think I have enough for a video, and I'll see if I can spice in some of the footage I've had from the past to make that point of the differences between the Husqvarna 365 build I did and the 2165, and why the 2165 has so much more power. And again, in summary, it's because of the different details like the air filter, the lower transfers, the muffler outlet, and the one little piece of the puzzle which I didn't really focus on is the ignition system, because the 2165 has the later ignition system that came off the X-Torqs, where it has a different timing curve which helps the low end, plus the compression helps the low end, and but it also generates spark at a lower RPMs, which makes it a little bit easier for it to get started. So hopefully I can turn this into a video. Hopefully you guys will be able to glean something out of it, but just so much stuff was packed in those earlier videos, and I see so many questions about it later. I'm like, you know, maybe I better fish around through the older videos to pull some of that information out, and then do things like this where I'll do a cover and then blend it with clips from the older videos. Talk to you later. Bye for now.